Today we are working on the distance formula. So very similar to the midpoint formula, we will be taking two coordinates and assigning them as x1, y1 and x2, y2, and then using those two coordinates to then go ahead and plug into the formula we are given in order to find the missing distance. So when I want to find the distance between these 2 points, I begin by assigning x1, y1 and x2, y2. So remember, we are plugging into x2 minus x1 squared plus y2 minus y1 squared. So I will take my x1 and put it where x1 goes, take y1, put it where y1 goes, take x2, put it where x2 goes, and take y2 and put it where y2 goes. So it's kind of almost like we are filling in those blanks. Notice that I am leaving my subtraction signs in the equation because when we start plugging in numbers, if the number is negative, we will find that we will have to deal with a negative negative. Now, you can take this equation right here and plug that directly into your calculator. But you have to include all the parentheses. You have to make sure that your subtraction and your negative signs are separate as well. If you choose not to plug it directly into your calculator, then you're going to have negative 2 squared plus 5 squared. Remember, when we square a negative number, we get a positive. So 4 plus 25 gives us the square root of 29. When we plug the square root of 29 into our calculator, we get about 5.4 as our decimal answer. So let's do the same thing one more time. So you're going to take that formula and you're going to make sure that you do not miss out on those subtractions. And we're going to assign the numbers. So I've got x1, y1, x2, y2. So here's my x1, y1, x2, y2. So then when I plug those numbers in, I will start with x2, that'll be 8. x1 is negative 7. y2 is negative 3. And y1 is negative 5. That will then give me 8 plus 7, because I have the double negative, plus negative 3 plus 5, same reason with that double negative, and that's then going to be 15 squared plus 2 squared. That'll give me the square root of 225 plus 4, which is 229. And when I plug that into my calculator, it's approximately 15.1 as my final answer. We can do the same work with a graph. The only difference is that we have to find the coordinates instead of being given the coordinates. So I have the coordinate negative 2, 3, and the coordinate 0, negative 3. So then I will go ahead and assign this as x1, y1, x2, y2. So I'll start with x2 minus x1 and y2 minus y1. That will then give me this negative negative becomes positive. So I get 2 squared plus negative 6 squared. So 4 plus 36 gives me the square root of 40. And when I plug that into my calculator, I get about 6.3. 3. And that's my distance. So remember back when we talked about circles, we had problems that we needed to prove or disprove, and we did that using a graph. We can also prove or disprove these by using the distance formula. And we can do that by seeing if the distance from this point that lies on the circle to the center, which here is 0, 0, is equal to the radius. So if we use these 2 points as my x1, y1, x2, y2, I should find that if it is a true statement that it equals the value of that radius. So let's go ahead and check. So we're going to have 0 minus negative 2 squared plus 0 minus 2 squared. That negative negative becomes positive. So I will then have 2 squared plus 2 squared, which is going to be 4 plus 4. So the square root of 8 does not equal the square root of 17. So this statement is false. And we get that by looking at comparing the radius with the distance. So let's try another one. I'm going to use this as my x1, y1, my origin x2, y2 at 0, 0. So I'm going to have 0 minus the square root of 2 squared plus 0 minus the square root of 2 squared. That's going to give me negative square root of 2 squared plus negative square root of 2 squared, which will be the square root of 2 plus 2. The square root of 2 squared just equals 2, and 2 plus 2 is 4, and 4 equals 2. So using that radius, it is in fact equal to 2, and so this is a true statement. Call this my x1, y1, my origin 0, 0, x2, y2. So that's going to be 0 minus 4 squared plus 0 minus 5 squared. That will give me negative 4 squared plus negative 5 squared. So the square root of 16 plus 25. 16 plus 25 is 41. And when I find the square root of 41, I find that that is approximately equal to 6.4, which is not equal to 6.5. So this is a false statement. And using the distance formula versus graphing, in an example like number 7, graphing-wise, it may have looked like 6.5 was on the circle, but when we use algebra, we can get a little bit more specific, and we can find that then we get a more precise answer to prove or disprove our statements.